highly pathogenic avian influenza A, H5N1, in dairy foods. I attended a last-minute expert panel on highly pathogenic avian influenza H5N1 virus. What a mouthful. It's bird flu. At last week's IAFP Food Safety Conference in the US. Here's what I learned. Sources and further information can be found at the end of the post. The panelists made it clear that the discovery of the virus in dairy herds and dairy food in the US earlier this year took everyone by surprise. They said they'd initially expected the situation to be resolved quickly because only a few cows were affected, and the industry thought it would burn out during the summer months. Months later, the number of infected herds continues to increase. We're now looking at a long time frame before this situation will be resolved, with panelists talking in terms of months, if not years. And here are a couple of quotes from panelists. This was a surprising situation for everyone involved. And that was a quote from someone from the USDA. And we thought we could get through this a lot sooner than we are. And that was from someone from the National Milk Producers Association. Background. Bird flu, or more properly called highly pathogenic avian influenza A H5N1, was discovered in dairy cows in the USA earlier this year, 2024. It was later discovered in raw milk. Genetic material from inactive viral particles was found in a significant number of pasteurized milk samples from retail stores. There have been concerns that the virus could be transmitted to people who consume dairy foods from infected cows. And I've been reporting on this issue in our weekly free food safety news roundups. Food safety risks from highly pathogenic avian influenza A, H5N1, in the dairy industry. What we know. Milk from infected cows contains the virus, and such milk may have the ability to cause illness in consumers based on the results of testing with mice. Pasteurized milk purchased from retail outlets in the USA has been found to contain genetic material from the virus. However, the virus was not infective in any samples. Pasteurization does inactivate the virus, with the FDA saying they are confident that commercial pasteurization is very effective at inactivating H5N1. Early information about the efficacy of pasteurization was based on tests conducted with benchtop pasteurizers, which do not accurately mimic commercial processes, and this led to initial concerns about the safety of pasteurized milk. However, the FDA, USDA, and their partner research laboratories are now categorically stating that pasteurized milk is absolutely safe. Cheese and other dairy foods made from pasteurized milk are also safe. Raw or unpasteurized milk poses a serious risk to consumers from the potential presence of the live virus in such milk. And just while we're on the topic of raw milk, I was gobsmacked to learn that raw milk consumption in the US has increased sharply since the public learned about this situation. Yes, you heard that correctly. Raw milk consumption has spiked in recent months in the United States. More on this later. What we don't know. We don't have enough information yet about how or if the virus survives in cheeses or other dairy foods made from unpasteurized milk. Among the panelists, the consensus seemed to be that the virus will eventually deactivate in aged raw milk cheeses, but the question is, how fast? The survival of the virus in dairy foods made from unpasteurized but sub-pasteurization thermally treated milk is likewise unknown. The Z and D values, thermal inactivation kinetics, and inactivation curves for the virus in dairy foods have not been determined yet. The fat content of milk makes a big difference to how the virus is inactivated. Low fat allows for faster or easier inactivation compared to high fat. The safety of milk and dairy foods made with high-pressure pasteurization, HPP, and ultra-heat treated milk was not discussed in the session. Why don't we know more? There are extreme challenges with understanding how the virus behaves within foods. Firstly, there are strict biocontainment rules that mean you need special laboratories if you want to study the virus. In fact, until recently, when this virus was reclassified, it cost until recently when this virus was reclassified, it used to cost $10,000 to ship one vial of sample across the country. Secondly, it's difficult to grow enough virus to make spiked samples for testing. Ideally, naturally contaminated milk is better for testing, but it is challenging to obtain enough naturally contaminated milk. Thirdly, figuring out whether viral particles are alive, infective, or dead in heat-treated foods is not simple and includes the need for highly specialised tests in which viral particles are inoculated into eggs to see if they're infective. Fourthly, it's extremely difficult to simulate high-volume food processing systems, such as continuous pasteurization, in a biocontainment laboratory. A $100,000 piece of equipment was custom built for pasteurization studies for use in the USDA lab, which had been studying the virus in poultry. And I'm going to quote here from David Suarez from the USDA, who says, "Trying to take a sample from the middle of a pasteurizer when it's under pressure is very difficult." How did this happen? It seems that the virus, which usually infects birds, infected one or more dairy cows and was then spread to cows on other farms through the movement of vehicles, equipment, and people. Animal health studies indicate milking equipment could be a key route of viral transmission. Can people catch bird flu from infected cows? Yes, people who work closely with cows are at risk, and there have been some cases of highly pathogenic avian influenza A, H5N1, in farm workers in the USA in recent months. There is minimal risk to people who do not work with cows. Are other food-producing animals also at risk? There is already a lot of science around the risk to pigs from bird flu. Pigs appear relatively resistant to infection. They can catch it, but they're not particularly vulnerable. There is already a strong influenza surveillance program for swine in the US that is likely to find it if it infects a herd. And that's a swine herd. It's not known whether the poultry industry faces risk from infected dairy cows. What about dairy herds in other countries? I asked the panellists from the National Milk Producers Association about what his counterparts in other countries are doing about this, but he did not know. I'm not aware of any infections in dairy animals outside the United States. Is the virus evolving? There is a lot of surveillance, and the virus is sequenced for every outbreak and every farm. It's also been the subject of surveillance in the poultry industry for years. There's not a lot of evidence that the virus is becoming more dangerous to mammals. Within humans, the Centers for Diseases Control, CDC, is performing routine surveillance for influenza, including for novel influenzas. What about raw milk consumers? During this session, there was a lot of talk from the panelists about how well the various government agencies, such as the FDA, USDA, and CDC, were cooperating with each other and with academia and industry. However, when the discussion turned to risk communications for raw milk, the panel had less to say. Two panelists said that consumption of raw milk seems to have increased in recent months. One theory to explain this is that people are freaking out about commercial milk and are concurrently being told on social media platforms such as TikTok that raw milk is safer, making it seem a better choice. Bizarrely, although the FDA reiterates its long-standing recommendation not to consume raw milk, it appears, at least to the knowledge of the FDA representative on the panel, that there are no new recommendations for consumers based on the current situation, nor do there appear to be any messages being actively distributed to consumers about the dangers presented by raw milk. Representatives of both the CDC and the FDA said they have information about raw milk on their websites, but do not have social media or traditional media campaigns about the new dangers from this virus in raw milk. In addition, panellists mentioned that safety messages from their agencies might be counterproductive because consumers have lost trust in the government. Takeaways for food professionals. For the dairy industry internationally, the big takeaway is that biosecurity measures should be reviewed and the movement of equipment, vehicles and people between dairy herds should be controlled. Note that new biosecurity protocols are voluntary in the US and based on government recommendations. There are no new federal regulations to address biosecurity risks from these outbreaks. Pasteurization inactivates highly pathogenic avian influenza A, rendering pasteurized milk and dairy products made from pasteurized milk safe for consumers. Raw milk has the potential to cause avian influenza infections in consumers. Raw milk, cheeses, ice creams and other dairy foods may also be risky. We don't know much about the safety of raw milk cheeses and have no thermal inactivation curves for the virus at this time. Takeaways for consumers. Don't drink unpasteurized milk or eat dairy foods made from unpasteurized milk in the United States. And in the email and the post, I have included the names of the panelists who I've been talking about. And I've got quite a long list of sources and links to references and further reading.